Hey guys, welcome back to Math 115. This is the last week of new material. We're doing chapter 9. Again, we're skipping chapter 8, jumping straight into chapter 9. Chapter 9 is about regression and correlation. And I just thought, again, I'd give you guys a quick reading before we get started. So, hello. Okay, let's jump into today's stuff. Hope you guys are staying safe from home or wherever you're at. Thank you guys for those of you who are continuing to work on everyone else's behalf, especially in the medical field. Anyways, without further ado, we're on chapter 9 on correlation. This is 9.1. And we're just going to spend this first video going over some of the main concepts. So what do you need to know? First of all, what is correlation? A correlation is a relationship between two variables. And in that correlation, data is typically written as ordered pairs. So you've probably seen this back in your algebra class, right? There's actually nothing much different from that. You have your x-coordinate, which is the independent variable, and your y-coordinate, which is your dependent variable. In fact, we call that x variable the independent variable. Or in statistics, they use a second name that's also sometimes called the explanatory variable, but it means the same thing. And then they call the y variable the dependent variable. Dependent because it depends on x. They also call that the response variable in statistics, but it really has the same meaning. As x varies, then y is dependent upon that. So think about the x variable as being along like the x-axis in the typical coordinate plane, and the y-axis as being the axis for the dependent variable. Or a scatter diagram. I'm guessing you might have seen this as well. The scatter diagram, all it is a graph of the ordered pairs, x, y, x comma y. So x is the x-coordinate, y is the y-coordinate, the vertical and horizontal. X is horizontal, y is the vertical, of paired data as points on a coordinate plane. And so you have two sets of data, right? You're pairing them up, and you just draw the points that are associated with them. We'll look at more examples, so you'll see what I mean later if that does not make sense to you. Okay, let's taking a step back real quick. We talked about this last time, but let's just take a quick look at where we are. We are in the sections or the chapters about inferential statistics. Remember, there's descriptive and inferential. Inferential is when you draw conclusions from the data that you have, instead of just describing it and displaying it. So we talked about three types of inferences. The first was estimation. That was back in chapter 6. Remember when we had those, what do you call those things? Intervals, yeah. We had those intervals for what the mean is at. And then hypothesis testing, that was what we did in chapter 7, where we formulate a decision about some estimation of some hypothesis that we have, right? We have some hypothesis about the mean in particular, and then we're just testing if that's accurate or not. Chapter 8 was also about hypothesis testing, but that's the one that we're skipping. If you're interested though, I think chapter 8 is actually kind of interesting. What it allows you to do is test if there's like a difference between two populations. So maybe you want to know if one population, I don't know, has higher or lower, just pick your statistic. Higher or lower heights or strength or whatever it is, tendency for anything. Now, the last thing is regression. This is what we're doing in this chapter. And what we use it for is to make predictions about a variable, about a statistical variable. And of course, for us, we're always focused on predictions about the means. That's what we're going to do this time as well. All right, let's move on. So what is the sample correlation coefficient? Sample because there's also something for the population correlation coefficient if you have access to the entire data. And that's represented by a different variable, but don't worry about that because we're only going to focus on the R one. All right, so R is the sample correlation coefficient. That's a measure of correlation strength and direction between linearly correlated data sets. Okay, let's just break this down. Strength means how strongly are they related to each other. So as one goes up, is the other guaranteed to go up or not? And is that are they really related to each other or not? If you have a weaker correlation, that means you have less likely of having an accurate prediction. It does not mean that the thing goes up higher or faster necessarily. It just means that they are related one way or the other, stronger or not. The direction could be positive or negative, and it could be positive with a high slope or a low slope. If it's positive, that means as one goes up, the other goes up. If it's negative, that means as one goes up, the other goes down. They have like this inverse relationship. As far as the correlation itself, the variable R, it's always between -1 and +1. So -1 is the smallest value it could be, +1 is the largest value. Okay, even though I say that, that's a little misleading, because really when we think about correlation, we think about the absolute value. If the absolute value is close to 1, then that means it's a strong correlation. In fact, that's written here on the right side. Strong linear correlation is when the absolute value of R is bigger than 0.7. And a weak correlation is when the absolute value is less than 0.4. For values in between that, so like let's say you're exactly at 0.4 or 0.5, 0.6, we call that a moderate correlation. For us, we're talking about only linear correlations, although there are other types of correlations that maybe follow some other lines, other graph, which, I'm sorry, not lines, but other graphs, like maybe a parabola or maybe some other complex polynomial or something like that. For linear correlations, this is the simplest case where everything is like a line. And this is probably what you've seen back in your early algebra classes. What else do I want to say about this? Basically, this is the only one that we have to worry about. We're only going to cover just the basic type of correlation. Okay, side note, you don't have to know this, but kind of interesting fact is that we can use slightly more complicated functions. Like right now we're just using lines, but if you change to polynomials, you can actually approximate any curve. That's like this crazy fact in that you learn when you're doing like calculus, that you can approximate any kind of curve using a polynomial with large enough degree. But anyways, that's unrelated. I just thought that's interesting. All right, so we have this complicated formula for how you calculate R, and this N is the sample size, right? You have the summations. These are your individual X and Y values, X from the first data set, Y from the other data set. So you multiply them and add them up. Then you subtract the sum of the first set of variables, multiplied by the sum of the second set of variables, divide by the square root of all this stuff, blah, blah, blah. But don't worry, this formula, you don't actually have to know it. All you need to know is really what it represents. It represents, again, the correlation strength and direction, right? And it's always going to end up being between -1 and +1. And I'm going to just show you how to cheat. You don't have to plug this whole complicated thing in. You can just press a button on your calculator and it's just going to pop the thing out super easy. In fact, I'll show you a couple different ways, using the same calculator we've been using and then using the Desmos calculator. Okay, what have I not talked about yet? So we talked about linear correlation. That's the only type we're doing. We talked about strong and weak. And the last is positive and negative. We've sort of alluded to these already. Positive linear correlation means as X goes up, so does Y. And then a negative linear correlation means as X goes up, then Y goes down instead. So this would be like a positive slope on your line, right? Thing goes up like this as you go to the right. And this would be like a negative slope on your line. Thing goes down as you go from left to right. Okay, I think that's actually all we need to know for the introduction of the topics. And everything else is just going to be working out problems. So I'm going to stop the video here, and then the next one we'll get into the actual questions.